So let us see a few more problems based on outer measure. So the first question is if m star of A is equal to 0, then we need to prove that m star of A union B is equal to m star of B. So here we'll use the finite additivity property to prove the following result. So now we know that B will be contained in A union B. So therefore by the property of outer measure, then if B is a subset of A union B, then m star of B will be less than or equal to m star of A union B. So let us call this as equation 1. Now by finite additivity, finite subadditivity property. So equation 1 will become, okay, for equation 1 il namukku m star of A union B undu. Ini finite subadditive aanengil this will be less than or equal to m star of A plus m star of B. But it is given that m star of A is now equal to 0 plus m star of B. So this will be equal to m star of B. So we are getting m star of A union B less than or equal to m star of B. So call this is equation 2. So from 1 we have m star B less than or equal to m star A union B. From 2 you have m star A union B less than or equal to m star B. So from 1 and 2, so combining both we will get m star B equal to m star A union B. So the required proof. Now we'll see a result. This will be used in solving the second problem. So the result says that if you have a sequence IN, so if sequence IN is a collection of open intervals which is covering all rationals between 0 and 1, then the collection sequence IN will cover the closed interval 0, 1. So this result we will use in the coming problem. So നമുക്ക് sequence IN എന്ന് പറയുന്ന collection of open intervals ഉണ്ട്. So this is a collection of open intervals such that it will cover all the rationals between 0 and 1. So if you have a set of all the rationals between 0 and 1, so if you have the rationals between 0 and 1, so that is contained in union IN. Then the result says that then the closed interval 0, 1 will be contained in union IN. So that is the result. Okay. So let us look at the second problem. The second problem is, so let A be the set of all rationals between 0 and 1, and let sequence AN, sequence IN be a finite collection of open sets covering A. Then prove that, so we need to prove that summation length of IN is greater than or equal to 1. So let us use the previous result. So it is given that the sequence in the covering of all rationals between 0 and 1. Then by the previous result, sequence in covers closed interval 0, 1. So therefore, closed interval 0, 1 is contained in union in. So therefore, m star of closed interval 0, 1 will be less than or equal to summation length of in. Now, closed interval 0, 1, that is an interval. So, for an interval, the outer measure will be length of the interval. So, that gives length of closed interval 0, 1. M star of 0, 1 and the length of 0, 1, that will be less than or equal to summation length of in. Now, length of closed interval 0, 1 is 1. So, we will get 1 less than or equal to summation length of in. So, that gives our required result. So, therefore, summation length of in will be greater than or equal to 1. And now, the third problem is prove that m star is translation invariant. So, we need to show that. So, if you have m star of a, and if x is any real number, then this m star of a will be same as m star of a plus x. So, here we are translating the elements of set by a plus x. So, set in that measure no matter. So, measure of a will be same as measure of a plus x.